All right. Good evening, everyone. My name is Sam Nasser, and this is the Cleveland C# VB.NET user group. Apologize for the technical difficulties in running the user group for the last 14 years. This is the first time it's ever happened. So
that's what they all say.
Yeah, that's exactly right. That's what they all say. I assume everyone's got an eval form? All right, very good. Let me just.
You're not gonna like it this time.
Restrooms, if needed, are immediately across from the elevators. Also, if you would please put your phones on vibrate, and we'll go ahead and get started. The meetings are free of charge. We meet every fourth week of the month. Thanks to DeVry for donating the space, and thanks to Inito for donating the pizza and pop, which went by pretty quickly. In any case, I want to thank you all for attending. Tonight's presenter is Lee Brandt. Lee is a veteran software developer, as well as a veteran of the Gulf War. He's developed in a variety of different languages, and he speaks both internationally as well as domestically. He tours at conferences as well as user group meetings, and we're happy to have him here tonight to discuss about Docker-izing your .NET environment. So with that, I will turn it over to Lee.
Okay. Yeah, you guys can't even see anything over there, can you? I'm trying to think if I can get out of the way some. I'm kind of a big dude, so getting out of the way is not really my strong suit. Okay. For the most part, it won't make any difference for the presentation. And the Docker commands, I'll say them while I'm typing them, so you guys know, and you'll just have to trust that what I'm saying is what's actually being shown over here. So like Sam said, my name is Lee Brandt. I am a developer advocate with Okta. We do identity management, access management as a service. Overall, friends don't let friends write auth. Nobody ever bought an accounting package because it had a cool login screen. So don't build your own auth, use somebody else, even if you don't use us. Okay, so a little bit about me. We'll kind of slam through this a little bit, but I am a programmer. I've been writing code professionally for 20 years this year. Unprofessionally a few years before that, although some people might say I still write unprofessional code, but I've been writing .NET since before .NET existed. So I actually have like a framed copy of Visual Studio .NET Beta, the little white cardboard 4 CD set in a frame, because I'm a dork. So recently converted vodkatarian, so I had to give up beer. It's a life choice. I mean, most people know me as Keeper of Keys and Grounds at Hogwarts. They know me from that. Started finding Bigfoot. I've been on 3 seasons. I still don't have a picture of me yet. Triathlete, I just put that in there to make sure you were paying attention. Very serious and very professional. Although I'm a big fan of the relaxation sports, you know, like fireplace sitting or fire pit sitting. Yeah.
Zeppelin fan too.
Yes. How did we used to get stuff into production, right? We'd write an app and then we'd go to the ops folks and we'd say, hey, I need to put my app in production. And they would say, okay, it's going to take 3 weeks. And we'd say, why is it going to take 3 weeks? Well, because I have to write a PO, and then I have to get the PO approved. And then once the PO is approved, then I can buy the server. Once it gets here, then I can put it in the rack. Then I can put it on the network. Then I can get all the software installed, make sure it's secure. Then I can put your app on it. Okay. And when ops people buy servers, do they buy the Intel Celeron processor servers with 512 megs of RAM? No. They buy the servers with 24 8-core Xeon processors and 5 bajillion gigs of RAM in them, right? And like 18 blade hard drives. And then they put your web app on there, and they just spent 15 grand on an app that's going to make your company $2 grand this year. So, and the server's now at like 2% utilization, right? And I'm not a network guy, I am a developer. So that's not really great for our company because we've just spent 15 grand on an app that we're only using like 2% of it, if that. And so VMs kind of help. And I've got a picture of a computer with the VMs at the bottom. So VMs helped quite a bit because we were able to actually use some of that powerful machine now, right? where I'm gonna like talk mostly to this group because you guys can see the pictures. VMs allowed us to get the utilization up, right? But we still have to, on each one of those VMs, I don't know about you, but when I start up a VM, I get decision anxiety. Like, how much RAM should I give it? How much hard drive space should I give this VM? What happens if I want to change my mind? Well, I'm going to take the whole VM down, change the hardware configuration, and then start it back up again. So, still not ideal. Plus, if you've ever worked in network ops, I have back in the day when I first started because I was the computer guy, right? If you've ever worked at those companies where you are the computer department. So I had to do some networking, but that was back in 97, 98. Wednesdays for Microsoft are like the worst days in the world, especially if you have a bunch of machines, because you got to log into each one of them, make sure the updates go through, or you could just turn on automatic updates and hope for the best. Not really ideal. But for each one of these VMs, you still have to do that. They still have to have an operating system. They still have to have whatever software you need to run your app, whether it's IIS or Tomcat or Apache or whatever it is, right? And remember that even when a VM is running, or when a VM is doing nothing, it's still taking up those resources, right? It's still taking up 4 gigs of RAM, and you still need some of that processor just to keep the operating system running, right? Because even when the app's not doing anything, the operating system is still running, right? So this is where containers come in. And I actually put this talk together originally because a couple of years ago, I was thinking, I should learn more about Docker. And so I did like a 6-month deep dive into Docker and Dockerized everything I did, as much as I could figure out how to Dockerize. And most of the people that I would talk to about Docker would say, I don't know really much about it. I really need to learn more about Docker. And then I got a job with this company that uses Docker. They have microservices. Everything's Dockerized, right? And every time I talk to the same people that I talked to a year or two ago, their answer is, I really should learn more about Docker still. So one of the other things I always get from people when I talk about Docker is, aren't containers just lightweight VMs? Okay, if you want to think of them that way, that's fine. But let's actually take a look at what the differences are between VMs and containers. This is where this side loses out because I got a bunch of cool graphics like boxes and colors and so I'll try and describe it to you. They both start with the host OS. On the box there's 2 blue boxes that say host OS. And the VMs, we start by putting a bunch of VMs on it. So I've now got 3 VMs on my host OS. Then I install the operating system for each one of those VMs. And even if you're using Linux where you don't have to pay licensing fees, you still have those resources taking up. But if you're a Windows shop, man, you have Windows licenses for each one of those as well. Then you've got whatever software you need to run that app that you're going to put on it. And then you can put your app on it, okay? With containers, you do the same thing. You can put the containers on there, on their host OS. Then you put your app on it and you're done, okay? And actually, this is a lie too, because usually the container contains your app. So overall, what you do is you take the container and you put it on a server and it runs, okay? So it kind of lowers the bar for what kind of resources are there. And the way it does this, and this is the cool graphics you're going to miss out on. So if people want to run over here and get a look at the blinking, never mind. So see, wasn't that cool? So the reason it's able to do this is because the containers actually share the host operating system resources, right? Remember, this is all built on Linux to begin with, right? And no matter what distribution of Linux you're using, whether it's Debian or Slackware or CentOS or Red Hat, they all use the same kernel at the very base, right? The Linux kernel. And it's the same with Windows machines. They all use the same Windows kernel at the beginning. And so since it's able to use those resources, Linux containers are actually able to, each one of them gets their own control group. Each one of them gets their own user space. So it's just kind of jailed off from the rest of the system in this file system, and it's using the resources. So instead of thinking about a container like a lightweight VM, a container really runs like an application does, right? So when I fire up Visual Studio, it takes as little or as much memory as it needs. If it's 2015, it's usually a lot, but it takes as much as it needs. If I'm not doing anything, it lets go of those resources, right? And it's the same with containers. When they run, they're going to take as little or as much resources as they need, as much CPU cycles, as much RAM, as much hard drive space as they need. Now, you can limit that in your setup of the container and say, use as much RAM as you want, but never go over 2 gigs, okay? And what this does is, in this scenario where I've got 3 containers on a host OS, if I get a denial of service attack on one of those containers, it doesn't kill all the other containers. It doesn't like hog up all the resources of the whole machine, right? So it'll just crash that one container, and you can deal with the denial of service attack just on that one container. So, how does Docker fit into all this? Where Docker fits is they have kind of emerged as the leader in containers, and the way they did that is because they standardized the container format. Okay, so they created an open standard for container formats and published it. And CoreOS, the company CoreOS, was really involved in this, and that was their mission statement, to create a standardized container. Now, what this does for operating system manufacturers is it means that I, as Microsoft, or as Debian, or SUSE, or whatever operating system it is, OS2 Warp, anybody remember OS2 Warp? That's the only one that doesn't have a Docker container.
That was an upgrade.
Yeah, yeah. Actually, I saw OS2 Warp, this is probably 10 years ago now. There was a company that serviced ATM machines. And the only reason I knew that most of the ATM machines ran OS2 Warp is because the little locked cage where they serviced them had a line of OS2 Warp boxes along the wall. Because I'm assuming they bought all the rest of the OS2 Warps that were available. So, now the operating system manufacturers can say, okay, I just need to make sure I have everything that the Docker toolbox needs to run on my host OS, and then I can run Docker containers, right? So now Docker containers can run on Windows, they can run on Linux, they can run on Unix variants, right? So let's take a look at what this looks like. The slide says, come on, fat guy, show us the demo. Okay, so here's our command line. Can everybody read that okay? Besides you guys, don't start. Okay, so installing Docker is super simple now. You just go to docker.com/download and download it and double click it just like you install anything else. It's not worth even showing you how to install it. It just installs. Once it's installed, what you'll get is the Docker toolbox on the command line that you can get to. So if you type docker info or -- version, you should get the version of the Docker toolbox that you're running. Now, one thing that's kind of confusing is if I do a docker -- version, I'll see version 17.03.1 -CE, which stands for Community Edition, right, and build whatever. But when you start looking for stuff online about Docker or Docker Compose or Docker Machine or any of the other things that go in the Docker toolbox stuff, they all have different version numbers. So like Docker Compose is just at 1.14 right now, just released like a week ago. So just know that this Docker version that you see here is the version of the Docker toolbox and not the Docker Machine or Docker Compose or any of that stuff, okay? Now, two terms that will help you probably 90% of the way there to get used to is containers and images. Everyone's done some object-oriented programming before, correct? Okay. Everybody knows the difference between a class and an object, right? A class is just a blueprint to make an object. Well, an image is kind of a blueprint for making a container, okay? So you can think of them that way, but actually an image is actually just a container that's frozen in time. So I can take a container and I can use that container to build another container with. And I can start from that starting point that container is at, okay? So if I wanted to see what images I have on my machine, I would just type Docker images. And what I get is a listing of repository, tag, image ID, created, and size. Okay, and you'll see I've got a few here. I've got the Postgres image. We'll talk about these here in a minute, the KCDC API images at the top. But I've got a Postgres image that's tagged with version 9.6.3 and a Microsoft.NET image that's tagged with 1.1.0 SDK project JSON. All right, so the reason that these are important is because first you'll see this thing that says repository at the top. That's the kind of the header of the table for the names, right? You would think that that would say like image name or something like that. But the repository is, if you think of it like a Git repository, the repository is actually Microsoft.NET. And this is a common naming pattern where you've got who owns it / whatever it's called. So this one's owned by Microsoft / it's the .NET repository. So the .NET repository is going to have a bunch of images in there that are tagged with different tags, just like you would in a GitHub repo or a Git repo, right? So I've got this one that's tagged with 1.1.0 -SDK project JSON. That's important because I don't have the necessary tools installed on my machine to run a project JSON .NET Core project, okay? I've got the latest version of the .NET framework installed on my machine, which uses the CS proj, right? Wow, I just threw up in my mouth a little bit saying CS proj. But this has got the old project JSON file in it, right? And the code we're going to look at is a .NET Core project that I wrote back when project JSON was the thing. But the important thing is the fact that since I'm going to be running in a container, it doesn't matter that I don't have the proper .NET framework on my machine to run it, okay? We've also got these image IDs, this is actually just the first like 12 characters, so it's not even the whole thing. And when it was created, this one 5 weeks ago, this one 23 hours ago, because I created it last night at the Detroit.NET user group. And then the size of the image. Okay, so if I want to get an image that I don't already have on my local machine, I can get it from Docker Hub very easily by just doing a Docker pull. And I'm going to go ahead and pull the Nginx image because it's kind of small, and the Wi-Fi is usually pretty good at places like this, so user groups it's not a problem, but conferences it can be a problem. And it'll say using default tag latest. So if I don't specify a tag, then it's going to pull the latest version of that image. It's important to note that in production, you never want to use latest, okay? Because just like any other GitHub repo, you're basically playing with the latest bits, and today's latest might not be the same as tomorrow's latest, right? So if you're going to production, people can push this stuff to Docker Hub anytime they want. So using latest, if you've got some sort of coordinator that's starting up 5 machines based on one image, you might actually get the first 2 images of latest, and then somebody might push a new image, and the 3rd and 4th and 5th image are completely different than the first 2. Does that make sense? So even though I'm using latest here, this is not advisable in production. So this is quite slow. Awesome. So we'll let that continue to go. And I'm going to start up another terminal window here. And we'll go back to our Docker images. Now they're changing the Docker commands. Eventually, they say they're going to deprecate these other commands. I think there'll be an uprising if they do, because I'll show you the new commands. And so Docker images is what you do now. Docker image list is what they want to change it to, okay? Which is fine for images, but when you start getting to Docker containers list and Docker TS, people are going to revolt because they don't want to type that. I mean, Docker commands are already pretty verbose anyway, and I screw them up all the time. But if I want to remove one of these images, so I'm going to remove this latest KCDC API image. And the way that I do that is Docker RMI for remove image. And then either I can use the repository name and tag, like this, KCDC API/API:/latest, or if I don't specify a tag, it'll automatically use latest, but I could remove the one that's tagged dev like that. Or I can use the image ID. And you might say, well, that's not really a very good option, but you only have to use enough of the image ID to make it unique in this list, right? So in this case, I could just RMI 9. And since none of the rest of those image IDs start with 9, it knows which one I'm talking about, okay? Generally, if I'm doing this, I'll usually use the first 2 or 3 characters just to make sure that it's unique. But usually after 3 or 4 characters, it's gonna be unique. But if I do a Docker RMI, we'll see that it removed this image and it removed a bunch of layers. So we'll talk about those in just a minute. Now, Nginx has downloaded. I'm doing things a little out of order now, but so I've got, when I do Docker images, I've got this Nginx tagged with the latest with an image ID. And if I wanted to run a container based on this image, then I would do a Docker run. And there's 2 switches that I added to this. So it says Docker run -it nginx/bin/bash is the command. So what this means is that I want to run an interactive container. That's what the I stands for. And it's interactive via a sudo tty shell. So just remember -it. That's almost always the switches you're going to run. Unless you're doing /d, which means to run it in daemon mode, which means run it in the background and then return me back to my terminal. But what we want to do is run this Nginx container based off of the Nginx image. We want to start the bin bash command is what we want to run at process ID 1. Okay? And for those of you who are not super familiar with Linux, the thing that's running at process ID 1 is a thing that keeps the machine alive. Okay? So if the thing that's running at process ID 1 exits, the machine exits. Generally, in a full-fledged Linux machine, the thing that's running at process ID 1 is this process that its whole job is to sit there, keep the machine alive, and when you actually ask it to die, its job is to, before it lets the machine quit, go through and find out what other processes are still running and try and shut them down gracefully. Okay, that's that whole process ID 1's job. But containers are made to run on a one-to-one type thing. So they're meant to be a machine that runs one app, and that's it. Okay. Now you can run more than one process in a container, but it gets kind of goofy. There's some images out there that'll allow you to run multiple processes when you start it up. The problem is if one of them fails, it gets kind of hard to figure out which one failed and kept the machine from starting up, right? Because you've got 3 or 4 of them running the machine. So you have to go through the logs and figure out which one was running at process ID 1, which one was running at process ID 2, and then figure out which one actually failed. So we're just going to start this up in interactive mode. And bin bash is what we want to run at process ID 1. So, for those of you who didn't see, that was lightning fast. I basically just started up a machine, which you can't really start up a VM that fast. So, it is now running, and I've got a command line that says root at 140ccc5b713/bang, or /hash, or #. Number sign is what we used to call it when I was a kid, so just me. Hashtag. So I can actually do a list of the file system that looks like any other Linux system. I can even do a who am I? It'll tell me I'm root. I am root. So if I go back over to my other tab here, the way I see which containers are currently running on my host machine is by typing docker ps. Now ps comes from Linux that says, I want a process list. Show me all the process IDs that are running. So we do docker ps, and it shows me, let's see if I can keep this from wrapping. Usually I have to make it big enough for people to see, but this room's kind of small. And I only have to project to like half the room, so. Go even one more farther down. And it's gonna wrap no matter what. Okay, so here's the containers that are running. I don't know why these other things are running. Didn't we just, oh, those are both running off of something else. Okay, anyway. So the other ones are still running from last night. So you can see they were created 24 hours ago, been up for 38 minutes because I just rebooted my machine 38 minutes ago. So when it rebooted my machine, it started those containers back up. But you'll also see that there's container ID, which kind of looks like the image ID that we had before. The image that that thing is based off of, the command that's running at process ID 1, when it was created and what its current status is. Over here you'll see ports, and it says 80/TCP, which means the ports that are open on that container is 80 on TCP is open to the world. Okay? And then the last thing is the names. And this one's actually named Lucid_Summit. If you don't specify a name when you start up a container, it will create one for you based off of a list of adjectives and a list of famous computer scientists' last names. So you'll get Angry Babbage or Stupid Boar or whatever. So just be aware. We got Dreamy McClintock last night, which was outstanding. So I've got these running. Now, I can stop a container two ways. One, I can exit whatever is in pip1. So if I hit exit, puts me back out to my command line, and when I come back over here and use my Docker PS, we can see that I only have two, or we can see, you cannot see, that there are only two containers still running, okay? And let's go ahead and stop all of these. And so I'll show you a little trick that I use all the time when I want to do something like this where I want to do something to all the containers that I have or all the images that I have. The good thing about Linux in the command line is the fact that I can use the output from one command to be the input of another command. So I can do a Docker RM for remove, and then I can give it another Docker image for a variable, a Docker command, ps-a-q. And Docker ps-a says show me all of them, whether they're running or not. And -q says run in quiet mode, which means it's not going to output all of this stuff, only the IDs of the containers. So when I do that, it should give me an error, which is outstanding. Cannot remove a running container. Oh, yes, I need to stop those. So if I need to stop ones that are running, I can do the same thing. Docker ps-a-q. An extra one in there, didn't I? So now it stopped both of those containers. When a command works, all it does is spit out the argument that you sent to the command. If it doesn't work, you'll get the nice stack trace like we did up here. Usually I don't ever run a command that doesn't work, so I've never seen this before. Totally surprised me. But now when I do a Docker ps-a, I can see I've got two, and the status is exited 0 23 seconds ago. So the 0 just means it exited gracefully, it exited correctly. If there was another command in there, another number in there, it would mean that it exited with some other error code. Now I can remove them all with my other command. And again, Docker ps, nothing running, Docker ps-a, nothing, no containers running or not on my machine. So, if I want to remove an image, so remember we just downloaded this Nginx latest image, and we found out that Lisa never used latest, so we want to get rid of latest, and we're going to download the proper version of Nginx. So to remove it, we do a Docker RMI and Nginx, and I can, again, either say latest specifically or just Nginx. Or I can use the image ID or just enough to make it unique in the list. Again, I'll almost always use a couple of them. And what we'll get is this thing that says untagged it, untagged Nginx latest, then that untagged the image ID, then it deleted 4 things. And each one of those 4 things is a layer on the image. So one of the things that Docker does to help save space on the host machine is each one of these layers is really a fully functioning image, okay? And if I created another image on my machine that had the same root as one of these other 2, it would be shared. So it doesn't actually download that layer again, okay? And I'll talk to you more about layers when we build our own in a minute. Okay, so when I do Docker images again, Nginx is gone. Trust me, Nginx is gone. Okay. So, everybody with me so far? Any questions about any of that stuff that we've covered so far?
Is Docker likely to be a place that can also run Java?
Yes. Yeah, I mean, I'm running .NET stuff. I'm actually working at Java Shop. I'm like one of 3 .NET guys that work there. So all of our services are Java services. So, and we do a lot of Python stuff as well. So,
Do you guys use hypervisors to host your Docker containers?
all of the stuff is hosted on AWS. All our stuff is. So it's hosted in VMs-ish on AWS. And I think they're using Kubernetes as the orchestrator. And when we get to Docker Compose, I'll show you some stuff that's new. That there's some things that we did because Docker didn't have these features that are now in it. But so let's go and talk about Docker files. Now, when I run a container from an image, I generally do not run it with a Docker run command. Okay, I'll run it from a Docker file. Okay, and so let's take a look at what a Docker file looks like. Actually, thought it was worth a try. So this is basically, the Docker files are just text files, okay, and they are they all start with a from line. So the very first line of the Docker file, and it's Docker file with a capital D, no extension. Okay, so it's just called Docker file. And the first line is always from, and it gives you an image name, just like we saw on there, just like you saw on the command line over here in Docker images. Wow. So I've got Microsoft/.NET tagged with 1.1.0 SDK project JSON. That's the one I'm building from. Okay. So instead of just doing a Docker run Microsoft.NET 1.10 blah blah blah, I'm just gonna, if I wanted to run this Docker file, I would do a Docker run, and as long as I'm doing it from that directory, so this is what I hate about having to restart my machine. So demos, I think that's where it's at. No. Docker. Okay, so now I'm in that same directory where this is running. If I were to do a Docker run and a dot saying in this current directory, it would use this Docker file to build my container based on this image, Microsoft.NET, blah, blah, blah. But I can put other stuff in there too. So I've got a command here that copies everything from my current directory into a directory on the container called /app. Okay? Then I've got a command in here called workdir that sets the working directory for /app in the container, which means all the rest of the commands that I run are going to run in the /app folder in the container. So that's now my working directory inside the container. Now, I've got these run commands here that, for those who can't see, it's just a run command with an array of strings that says .NET and restore, the 2 strings in the array. And you might say, wow, that's a really weird way of running commands. This is called the exec style of running commands. You can run commands by doing run.net restore. And you might think to yourself, why wouldn't you just do that? That seems like a whole lot more straightforward than this kind of dumb way you're doing it up here with the arrays and the strings. The exec style actually guarantees these won't run until the container has finished coming up. Okay? So the exec style, most of the time they will because the container comes up pretty fast. But they're not guaranteed to run once the container's up. Okay? They might run while the container's still bringing itself up. So if it's something that doesn't need the container to be there, like I'm setting some command line variables or some things like that, then it doesn't matter. The other thing that you can get from this, from the shell style, which is the other style, is I could do something like this. Restore and build. So what I've typed here is run.net restore &&.net build. Okay, this is standard Unix command line stuff that says run.net restore, and then when that's done, run.net build. Okay, and this is important when we start talking about image size. Okay, and we'll talk about that a little bit later. But for right now, I'm just using these two exec style commands for running .net restore and running .net build. And the last thing I'm going to do is I'm going to expose port 5000 on TCP out to the outside world by just putting in expose 5000/TCP. Okay, so if I wanted to run this, then over here in this folder I would just do docker run doc, and it would know that the context for the running of the docker run command is this current directory, and so it's going to look for something called docker file, capital D, no extension. Okay, but we're not going to do that either, because I don't normally run it just straight from docker run and the docker file. And so I know what you're thinking. What would you say you do here? Okay, I use Docker Compose. Okay, and most people do as well. So the way Docker Compose works is you put together this YAML file, and a YAML file is just a text file that uses intention to kind of put things together. And they always start with a version. Version 3 is out now, but I'm still using version 2 here. And the first thing I'm going to have is this services header, and it just says services with a colon after it. Then the next line is indented, and these are all the services that I want to run. And you can call them whatever you want. Here I've got two services that I want to run, one called API and one called DB. Okay? And if we look at the API service, here's the instructions for how to build the API container. The image that I want to run, okay, so this image says, look for this image. If it doesn't exist, look on Docker Hub and see if it exists and do a pull. Or, if that doesn't work, look and see if there's a Docker file that you can use in this current directory to build an image called that. Okay, so that's what's going to happen the first time I run this, is it's going to create an image based on that Docker file called kcdc/API:dev. For those who don't know, I run a conference in Kansas City called KCDC, the Kansas City Developer Conference. Okay, and this is the API, or like a scaled down version of the API. And this is kind of how we develop for the KCDC apps. So I'm going to tag this with dev. The container name that I want, once you've built that image, I want you to run a container from that image. And I want you to name it KCDC_API instead of Dreamy McClintock. Okay? Then the build context, it actually assumes that the build context is this directory. But I wanted you to see this in case you wanted to put your Docker file in some other directory. You can specify that here by specifying a build and a context. Okay. Inside of build, there's several other things that can go inside of the build command. But context is the most common one because people will put their Docker file in some folder that's not the same folder as their compose files. So Here's the first part of the super unicorn magic of Docker Compose, okay? Remember, in my Docker file, the last thing I did was expose port 5000 on TCP. Over here, in my ports section of my Compose YAML file, I'm going to say map port 5000 on the host to port 5000 on the container. Because while this port 5000 is exposed, the only way to get to it is once it's spun up, is to figure out what the ID is of the container. Remember we saw root at 1, 2, 3, 4, whatever it was, right? The only way you can get to it is to take that hash, and it's actually like 200 characters long or whatever, and go to that :5000 to hit that port. What this does, this ports map, is say map localhost port 5000 to the container's port 5000. So I don't need to know the container's ID at all, which means I can go to localhost port 5000 and actually hit port 5000 on the container. Make sense? Okay. This depends on says this service depends on the DB service being started first. So here's my database service. This needs to start first. Now, what you'll notice when I actually run it is the API service will start, or the DB service will start, and then it will immediately start starting up the API service. Because the other thing you can put in here is a health check, and you can give it any command line command, and it will check it on that service. So let's say I wanted to do like a ping on port 5432, which is what Postgres starts on, right? If I wanted to do a ping, then it actually wouldn't start building the API service until that ping was successful to port 5432. Make sense? Okay. So you can do anything in there like check to make sure Tomcat's listening, make sure that the .NET framework is installed, whatever you can check via command line on that service, you can just put in a command here. Here I'm setting some environment variables. It's just environment : and then indented all the environment variables I want to set. This one is for our watcher because the command we're going to run in the PID1 is .NET watch run. So that's going to be the entry point. So we want to set the environment variable .NET use polling file watcher to 1 so that every millisecond it checks to see if there's any changes with the code. I'll come back to volumes here in just a minute, but networks that this service belongs to is the KCDC network, and then the last thing is just restart always if you can. Okay, so if it goes down, try and restart it. Now the volumes is the second half of the super unicorn magic. So volumes, and I've got indented -.:/app. So remember, I'm putting everything in /app in the container in my Docker file. So like the second line of my Docker file is copy ./app. What this does is it actually negates that from, because this is my dev.yaml file, this is dockercompose.dev.yaml. And since this is for development, what I'm going to do is I'm going to actually map my current directory on my host machine to the /app folder in the container. And if you've ever used like symlinks or mounting in Linux, works just the same way. So every time someone goes to /app in the container and pulls up, I don't know, index.html, it's actually pulling up index.html in my current folder, where it's at, okay? And we'll see why that's important here in just a minute. And here's the DB service. The image that I want you to build it from is from Postgres, tagged with 9.6.3. The container name is going to be called KCDC_DB. The environment variables I want to set, there's one called PostgresDB, which is going to create a database called KCDC. Then it's going to set a password called Docker for this Postgres user, KCDC_app. Then I'm going to map port 5432 on my local host. Again, this is only so that I can actually pull up something like pgadmin or Visual Studio Tool, or what is it, SQL Server Tools, Management Studio Tools, whatever it's called, to be able to actually hit the database, okay? So I don't have to go to the ID of the container :5432. This is another volume where I've mapped in the container /docker-entry point-initdb.d, which is a daemon file, daemon folder, to, in my current directory, a folder called DB, and we'll see it right over here. And this is a specific thing for Postgres. When a Postgres server starts up, it looks in this folder, docker/entry point -init db.d, and anything in there that's a SQL file, it runs. So in my local file here, I've got some SQL that creates a speakers table, creates a registrations table, creates a sponsors table, okay? So those are gonna run when the Postgres container starts up. The networks that this service belongs to is the KCDC network, and the aliases for this are Postgres. This is 3 hours of my life that I'll never get back. You must alias the database, or you'll not be able to reference it on the network. Okay? So, and then I've got restart always. Okay, so the networks thing that this belongs to is just a thing that, and you can call this anything you want. I've called it KCDC-network. And the driver that I'm using for this network is I'm gonna bridge the host network. What this does is, since both of these services now belong to that KCDC network, they can talk to each other as if they were the only 2 nodes on this network, which means they're allowed to access each other, but outside things can't access them, right? Except for places where we've exposed something like port 5000, okay? Now, when I run this, assuming I haven't screwed anything up, which is kind of a big assumption considering, I run it via a command called docker-compose. And in this case, I need to give it a -f flag switch that says, I'm going to use a different file name than you're expecting. By default, it's looking for a docker-compose.yaml file. But this one's for development, so it's called docker-compose.dev.yaml, right? So I use the F switch to say, this is the file that you're going to use to compose this, and up. So really the command is just docker-compose up, but I have to give it F switch because I'm using a different file name. And when I do this, you'll see that it's creating KCDC DB first, then KCDC API. And actually, we should have seen the, Lee may have screwed this up, but I expected it to see some commands coming out of the Docker file, so it created the image. But let's go to this other thing and do Docker images. Oh, I didn't, that's right, I didn't delete that one, I deleted the latest one, didn't I? Okay. So hopefully it's not screwed up. But if I open up a browser now and go to localhost port 5000, because I've exposed that and I've mapped it to my localhost port 5000, and I just happen to know that my app's running at /API, so I'm going to go there. And when I do that, I get this KCDC API call coming back from Docker. Now they can't see, but I expected oohs and ahs over here. Oh, jeez. All right. But if you don't believe me, let me go into my code here in the default controller. Say, seriously, this is running from Docker. And when I hit the save button, oh, I didn't. Look at my command line. You'll see it's pre-compiling, and it's going to try and see if the tables exist again. It does. And when I come back over here and hit refresh, it says from Docker, seriously. Because I used the volumes in my compose, where I said the volumes for this /app actually or my current directory is actually /app in the container, right? And there's other things too, and we'll see them in a minute. But I've created /app in the container to point to my current directory. So when I make changes, .NET watch run actually checks it, does the build, and reruns it. So now and it takes a few seconds, a little bit longer than running locally, but something that's important to note, and this is something that I figured out through trial and error, you'll see I'm running Microsoft, I'm basing this Docker file, the from command, is from Microsoft.NET tagged with 1.1.0-SDK-project.json. And that's because it's only going to install in the container. The container comes with just the SDK installed and not the whole .NET framework, okay? So if you use something like, there's another one called ASP.NET Core. If you use that one, it's going to install all the tools for everything .NET related. And that one takes about 30 seconds every time you hit save for it to rebuild and rerun the container. The SDK takes about 5 seconds. So I use the SDK most of the time I'm doing this, excuse me, because it's a lot faster, okay? So now, if I wanted to stop this, I can stop this here by just hitting Control-C. And I will let you know, only about half the time does it gracefully stop them, but we'll see. Yep, error aborting. So, when I come over here, and I do a Docker PS, I don't know why I'm bumping that up, like if I bump it up big enough, they'll be able to see it, but we'll see that I've got the Postgres image had a container built, and the KCDC API dev, so I had one called KCDC API and one called KCDC DB, and they're actually both still running. Okay, because when I did the Control-C, it didn't actually go through and quit the stuff like it was supposed to. So you guys already saw this, so sad for you, but if I want to Docker stop these, I can either use the container ID or the first 3 characters of it, stopping this first container that starts with F8B, or I can use the same thing that we did before with our fancy little Docker PS-A-Q. So what I've done here is I did Docker stop, and then I put a $ with parentheses, and I can put another command in there. And the output of that command becomes the input for the other command, okay? So the PS-A-Q lists out all the Docker containers that are running, or actually all the Docker containers in quiet mode. So it just puts out the IDs. And it'll take just a couple seconds here, and it'll output both of the IDs of both of those containers. And if I do a Docker PS-A again, you'll see that they are now stopped, exited 6 seconds ago, okay? And we'll actually remove both of those containers same way. And now my Docker PS-A says I have no containers running or not. And if I come over here to Docker images, I can see that I've got the image here, KCDC API tagged with dev, and I can remove that if I wanted to with RMI, KCDC/API:dev, or the image ID. Now, when I do Docker images, I only have those 2 images there. And if I actually do a Docker compose from here, with the /-f, you'll see it starts, oh, not from there, from the current directory. It has to be in that directory. You'll see it starts with step 1 of 6, step 2 of 6. This is the Docker file. So it noticed that the KCDC API dev tagged image didn't exist, so it's creating it from that Docker file. And you'll see it says it's restoring packages because it's running this .NET restore. And that's going to take a while because we're on the network, so I'm glad I still had actually this image. But we're going to go ahead and quit that. Let's see if it actually tried to create something. No. Okay. This is what will happen when a Docker compose to create an image or a Docker build of a Docker file, when it fails. When you do Docker images or Docker image list, you'll see this repository of none, tag of none, you've got an image ID, and it's basically an incomplete image. So this is when you really need that image ID, because I can Docker RMI 842. Since it doesn't have a repository name, I can't refer to it that way. So I have to refer to it by the ID. And so it deleted the 3 layers that went with that image. It didn't need to untag anything because the tag hadn't actually happened. So when I do Docker images again, it's now cleaned up. Okay? Any questions about running Docker images from Docker files or Docker Compose? Okay,
I have one question.
yeah.
If your host machine is a web server, so that's listening on port 80, you have 3 containers all listening on port 80, can you line to all 3 of them?
Well, you wouldn't be able to have
Couldn't do that.
multiple containers listening on, just like you can't have multiple apps running listening on.
One.
You can map one of them to port 80, and so if you needed to have like a farm, then you just have the how's it called? The
Router?
the round robin load balancer. You have a load balancer port mapped to port 80, and then each one of those can be mapped to a port on the load balancer.
Okay, so that follows the same process.
Yeah.
Okay.
Good question though. Any other questions? Okay. Now I've been going for, how long have I been going for? We didn't start at 6:30, so I have no idea how long I've been going.
You got plenty of
About an
time.
hour.
Got 40, about an hour. I'm now going to show you why the last hour of your life was wasted. No. I love doing that to people, but. So, if you're in Windows, again, like anything else, the Docker toolbox is just an app. So once you've got it installed on Windows or on Linux or on Mac, all the commands are the same. Makes no difference. But generally when I talk to .NET user groups and I say, go out to the command line, the first thing they do is go, oh, the command line, really? Don't you have a button I can push? This is your button. Okay, so if you have Visual Studio 2015 Update 3 or higher, so you have to have Update 3, and you have the Docker, well, you don't even have to have the Docker toolbox installed, but it won't work without it. You can still install this extension, it just won't do anything for you. But the extension you can install, you go to extensions and type Docker and search for it, and there's one called Visual Studio 2015 Tools for Docker. And it's marked as preview, but it's been marked as preview for the last year. So once you've got it installed and you create a new project, so we'll do File, New Project. We'll do File, New Project. We're going to start this ASP.NET Core web application. I didn't clean up my machine because I think we're 37, 36 was last night. Okay. And we're going to call it a basic web application, the web application 37, whatever. Once it's restored the packages, which should only take 20 or 30 minutes. Once it's restored the packages, actually, once you've got this thing up and running, if you go to the project menu, you'll see this thing that says Add Docker Support in the project menu. When you click on it, it's going to create a Docker ignore, a Docker compose.dev.debug.yaml, a Docker compose.dev.release.yaml, and a Docker compose.yaml. I'm not sure what dev.release is, because for me, dev and release are mutually exclusive, but that's Microsoft's naming convention. So it's got a Docker file. And if we look at the Docker file, it looks very familiar. It starts from Microsoft ASP.NET Core 1.0.1 because that's the .NET framework that I have installed on this machine. So if you're running it from by the way, Visual Studio 2017 has this stuff built in already. You don't have to install the extension. It's already built in. So actually when you do File New Project, there's a little checkbox down at the bottom when you're creating a project that says Add Docker Support, and it just creates the files when it creates the project. So here's my Docker file. It's going to come from Microsoft ASP.NET Core 1.0.1. The entry point for this application is going to be running the .NET command against Web API 30 or Web Application 37.dll, which is going to be in our bin folder once it's been built. The argument, so it's setting up an argument that says the source is my current directory, because it then switches to what I had done in mine is just done the copy up here, copy to /app. So copy dot to /app. What it's doing is it's setting up an argument that says source is actually pointing to this local directory, and then it's setting the working directory to /app. So the problem is Now this copy command that's down at the bottom here is gonna run in/app on the container. So that's the reason they had to set this variable up here. So they're doing the same thing, they're just doing it backwards. Okay, it's a little bit, to me, it's a little bit harder to read. And then they're exposing port 80. If we look at the dev debug.yaml, we'll see again, it's version 2. The services, it's called web application 37. The build, there's an args that says the source is actually an obj docker empty, which I don't think this actually does anything. Just like this doesn't do anything, the entry point being tail -f dev null. So look in the garbage and show me whatever is the last thing in there. Whatever.
Dev null is nothing.
Yes, dev null is nothingness, the black hole that not really even the garbage, but and we've got some environment variables that it's setting. Still using the .NET use file watcher. It's got a couple other volumes set up. So it's got /app pointing to my local directory, but it's also got my NuGet package directory in my user folder, pointing to /roots.nuget/packages, and this last argument, the :ro on the end, says set that to read only, which basically means it's going to be using the NuGet packages from my local machine. So when it tries to go to /root/.nuget/packages, it's actually going to be hitting my local NuGet packages, which is what we want. And this is the CLR debugger. It's doing the same thing. Use my local CLR debug folder for /CLR debug in the container so that we can actually do debugging. Okay. On the Linux side, it's a little bit more complicated than just setting the CLR debug folder. But the cool thing is once this is created, if I haven't screwed anything up, when I hit F5, you'll see the, well,
Do you think that
you'll see
tail
the
of
output
is just
folder.
to keep it alive, the follow?
Yeah, and that's just the entry point that's going to run at pid 1,
Yeah.
so it just stays running. So you'll see, actually, it runs a docker compose command when you hit F5. So in the output window, under Docker, you'll see it did a, now I can't scroll back up. But the last thing it did is it did a Docker inspect, and it actually mapped port 80 to whatever port the app's running on, because in Visual Studio, it doesn't always run on port 5000, right? It runs on some random numbered port that it's going to create when you hit F5. So that's what that last little piece was, to say, hey, whatever we started this thing on, map port 80 on TCP on my local host to the port 32769 in the container. Okay, and then it starts it up, and it's actually running inside the container. So I've got my debugging, and I can actually hit breakpoints if I wanted to. I can come into my controllers in my home controller, go over to my about, set a breakpoint on the very first line of the about action. Come over here and click on about, and it'll hit that breakpoint, just like anything else. And now everything's running in a Docker container under F5. Okay. And when I stop this, it doesn't actually stop debugging. So unlike the regular run, because when I hit stop over here, it's actually going to stop and kill both of those containers. So I should be able to see over here, web application 37 should both be stopped. Nope, status is up for the last minute. Okay. So it's didn't do anything. It's supposed to stop it and kill it so that it rebuilds it every time. Okay. That's not even worried about that. Okay. Any questions about the button that keeps you off the command line for those who don't like the command line? Okay. Last thing. What if I'm hosting in Azure? How do I get Docker containers up on Azure? If I go to portal.azure.com, that's the one I want. This is down a little bit, so There's two ways to get Docker containers onto, well, three, if you count creating a VM and then pushing the container to a VM. But there's two ways that Azure is already set up to handle Docker containers. The first way is with their Azure Container Service. So if you just search for container under Azure Container, there should be Azure Container Service. And if I say I want to create one of those, one of the first things it asks you is, what do you want to use for your orchestrator? And it has three choices that you can use by default. DCOS, which is created by Apache, Kubernetes, which is a Google product, and Swarm, which is created by Docker. And what orchestrators do is, let's say I wanted to, for instance, I wanted to run this KCDC app that I have with the API, the database, and the web front end, some React app, or what's trending on Reddit now? Vue? Is Vue the new hotness? So whatever the front end is. I can have an orchestrator that orchestrates running those three things. A more common use of an orchestrator is if I wanted to set up a farm of 4 of these web apps running, okay? And I wanted to load balance them, like put engine X as a load balancer in front of those, right, as a reverse proxy. Which, by the way, .NET Core runs using Kestrel instead of IIS, okay? Which to me is awesome, right? Because if anybody's ever had an app that doesn't get used overnight, the first user in the morning gets the suck lollipop, right? So they're the ones that have to wait to spin up a new app pool. Kestrel takes it all out of the works. But Microsoft still advises that it's not ready for production. So if you're going to use it in production, put a reverse proxy in front of it. So a lot of the times you'll see people pushing .NET Core apps with Nginx in front of it as a reverse proxy. So all it does is you come into Nginx, Nginx forwards the call to Kestrel. So like I said, the more common scenario is I've got a farm of 5 web servers that I want to run. Or if you're doing microservices, I've got this service that is my checkout service that actually charges their credit card. And I have 15 instances of that running that are load balanced. The orchestrator orchestrates starting them all up. When you do an update, it does rolling updates. So it brings one machine down, does the update, rebuilds it, puts it back in the cluster, brings the next machine down, updates it. So it does the rolling updates. Also, at least with Swarm, and I'm pretty sure they're all the same way, let's say you want 5 of this service running, 5 instances of this service running. When you set it up, you say, I want 5 instances of this running. If one of them crashes, it will automatically start up another one and put it into the cluster, okay? So it'll let the load balancer know about it, so it keeps 5 instances running because it said you said you wanted 5 running, okay? So to me, that's pretty cool. Swarm is a little bit difficult to set up. I've been told that Kubernetes is a whole lot easier, but I've only messed around with Swarm. So never even messed with DCOS. Now, that's if we want, generally if we want to run more than one instance. But let's just say we just did this web application 37 and you just wanted to test it and see, I just want to put that Docker container up there and host it in Azure. There is a way to do that as well. So if we look for, actually in app services it'll be easier to get to. If I go to app services and say add, I can search for what app service I want to run. Web app is the top one right here. But what we want to run is web app on Linux. And it also says in preview, but it has been in preview for about the last 6 months. So if I say web app on Linux and I want to create one, the first thing it'll ask me is, what do I want to use for my container? And by default, it has some built in. Node 4.4 all the way through 6.10. .NET Core 1.0 and 1.1. Already set up Ruby and a couple of PHPs. Or you can actually point it to a Docker Hub repo and actually pull it from Docker Hub. You can also pull it from a private registry, so you don't have to use Docker Hub. There's also another one called Key, Q-U-A-Y. I think it's QUAY.io. It's another public registry. But they have private registries too. They're paid, but or you can set up your own private registry. I know there's a lot of companies that don't like to have things outside of their walls, especially stuff like code for compliance reasons. So you can set up your own private registry. As a matter of fact, on Docker Hub, there is an image for creating a Docker Hub registry. So you can download the image and run it in a container that hosts all your images for your containers. Kind of inception a little bit, but so that's all you do, and it'll basically run the container just like it runs your web apps. And I've got one created here on my dashboard called Docker First. And if I go to the settings for it, we should see, whoa. I should be able to see in the settings, the Docker container, that it's looking at Docker Hub, a public repo called kcdc/API::latest. Okay? Because like I said, never deploy latest into production. Now, this is a demo, so obviously. But that's all you need to do is tell it the image name, and it's going to Docker Hub, and it knows how to get to Docker Hub. Now, if you give it a private registry, then you have to give it the whole URL of how to get to that image. But basically, it's going to build based on like that Docker file. It's going to build that code. But when I push it to Docker Hub, hub.docker.com, in my registry, why I'm not signed in? When I go to my registry, organizations that I belong to, KCDC, I've got KCDC API, which is tagged with latest. Now, if I search for Microsoft, I can see there's .NET and ASP.NET Core. And if I look at one of these, I'll see there's a bunch of supported tags. 1.0.5, blah, 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 blah. And let's go back to the .NET one, because that's the one I'm using, and it's going to have the project JSON one is down here, and it says it's no longer going to be supported after, used to have a date in here, I thought, but if I look at any one of these, there are two different tags for this. There's 1.0.5 runtime Jessie, which is running basically off of Debian Jessie. So all the Linux containers that Microsoft uses are based off of Debian. Okay, they used to be based off of Alpine. They've switched over. The Nano server is actually a Windows container. Okay. Now I will let you know that the Windows containers, there's two basic ones that you're going to use: Nano server and Windows Server 2016. Nano server is 1 gig in size. That's the small one. Windows 2016 is 10 gigs in size. So, and I'm not sure, right now they're all preview. I don't think they're legal for production because I don't think they figured out the licensing yet, how they're going to sell it to you, how they're going to charge you for it, right?
So it's like a VM.
Hmm?
It's like a VM.
Yeah, I mean, it's a container that's running Windows. Something else, you cannot run a Windows container on Mac OS or on Unix. Because remember, it's using the underlying kernel, and the Windows kernel doesn't exist on the Linux machine, right, or a Unix machine. You can run Linux machines on Windows, because you have to have Windows 10 or better to run Docker anyway, and Windows 10 has the Linux subsystem built into it, right? So it already has the virtualized Linux kernel underneath it. That's how it runs the Ubuntu bash shell and all that stuff. That Linux subsystem is there already.
So these creators update.
Yes. So so far I haven't had any problems running any of the Unix containers on in a Windows environment.
But isn't that using like Hyper-V and like their
Yeah, you do have to have Hyper-V turned on because it's virtualizing the Linux kernel.
Okay.
Yeah. And it used to be that up until about a year ago, when I first started with this, there was all this stuff you had to do to get it all set up. Like you had to install run RC or dev RC or something like that on your Linux box. Then you had to do something weird on Windows to get it to work, and none of the Windows containers worked. Now it's a whole lot smoother. Some of the Windows containers are still a little janky, but I think a lot of it has to do with the size. 1 gig, and because remember the sizes of these that we were looking at here, they're 269 megabytes and 581 megabytes. So most of them, that's actually a pretty sizable container. Most of them are 200 or 300 megs. But they don't have to carry the weight of the Windows subsystem. So, but if we look at these Docker files that created them, you'll see them doing this thing I talked about: run apt-get update, ampersand, apt-get install, curl, and remove recursive force the apt lists. In our Docker file here that we had before, whenever you run one of these commands, so when I copy everything from my current directory into a folder called app on the container, it creates a new layer. Remember we were talking about layers there when we deleted the image. You saw that there was 4 or 5 layers that made up the Nginx image. Each one of these layers are forkable now, but each one of the layers comes with a little bit of weight of its own. It's not very much, but they can add up. And each one of these commands, so this image here probably would have one. I don't think that creates a layer, but this one would, and that one would. Okay? So we'd probably have 4 or 5 layers just from this image, plus whatever layers came from this, right? So just be aware that every one of these commands you do is going to create a layer. So what they do is they use the shell style. Even though you can't guarantee it's going to happen after the container's up and running, most of these containers are so fast that it's probably going to anyway. So they're taking the chance that this is going to fail because it doesn't come up in time. But this creates a layer. And so what I've seen from most of the Docker files is that they will, even though you'll see another run down here that chains together a bunch of other commands, try and group them together into a logical layer. So if I wanted to, for instance, start with just a Debian Linux system. By the way, if you don't want to start with anything and you want to build your own thing, the from line is from scratch. So if you say from scratch, it doesn't do anything for the from. Okay, and then you could download and install a Linux system that you want to put on it. But if I wanted to, for instance, start with a Debian image, and then I want to install Apache and Apache utils together as a logical layer, then I would just ampersand them together, right? Or if I wanted to do Apache utils, and gzip, so I can gzip my results before I compress my results before they go out, right? Then I would put those together in a logical layer. Because remember, you can fork from these, so I can start from that layer and build another container, right? So just try and keep them. The very first thing I did when I saw this and saw that each one of those things made is I had all my runs all put together, so it would just create one layer. But the problem is then later that image is really not useful for anything else, right? And I don't get the benefit of being able to share those layers across other images. Once you start doing things like this, where you're putting things together, that this all has to do with just getting the .NET framework and stuff installed on that machine, then I can actually share this layer with other images that I may have on my machine. Does that make sense? So it just maximizes the amount of stuff you can put on your host machine without overwhelming it.
So this is analogous to if you had a VM, you would install the stuff manually.
Yeah. Or use something like Chocolatey or something like that, right, to install it all. But you can do it all right here in the Docker file. And actually, there's one in here that's the Docker Nano server. Actually, I think it's even on this VM here. The Docker Compose. Oh, I thought I created a Docker. Oh no, I created one over here. This is the Windows one that's coming from Project JSON Nano server. It does some of the same stuff, but in here, I thought I saw one that was a PowerShell. Yeah, there we go. So the shell is actually going to be PowerShell. So all the run commands are all PowerShell commands. So you can use whatever shell you want. It's just you got to give the shell command that lets Dockerfile know what shell to use. Okay. So this is my contact information. Developer.okta.com if you want to use Okta stuff. Now is actually a really good time to get started with Docker if you need it, because we're putting a lot of development cycles into the developer experience. So if you're the type of person that likes to give feedback and see your feedback already in the product, now's a good time. That's my email address, lee.brandt@okta.com, AOKTA.com, and I'm at Lee Brandt on Twitter. I'm also, my GitHub repo is Lee Brandt, and so you'll see a lot of, this demo code and the Docker file and the Docker Compose file are all out there in my Docker demo repo. So check it out. Was this useful at all?
Yes.
Okay. Okay, well, thanks very much for coming, and thanks very much for sitting in the dark and pretending like it was interesting. Any other questions?
What
Oh,
does
yeah.
Okta do?
Oh,
Any,
how come?
Okay.
Sorry, you go first. You're here.
thanks. When you did your deep dive, what resource did you use, particularly thinking of Pluralsight or anything?
Yes,
When you
so
started?
actually I should mention this because I learned a lot of what I know from Nigel Poulton's courses on Pluralsight.
Okay.
He has several Pluralsight courses. One of them is a 1-hour course that just takes you from writing a little Node app and putting it into a continuous integration and continuous delivery thing that deploys to AWS.
Okay.
So Circle CI that's how I found Circle CI for continuous integration, because Circle CI, even if you don't have a Docker file, it does all of it in Docker. So it creates a Docker file based on what it thinks your code is. Looks at your code and says, this is a .NET app, so I need that .NET Docker file. And, well, you can give it a Docker file and have your own specific Docker file, and it'll run your tests on the Docker container that it's ultimately going to push out to production. So the environment that you're coding in becomes the environment that the tests run in, and becomes the environment that it gets deployed. So the environment's the same all the way across, which is very, very cool. He also has a deep dive course where he talks about what's going on the networking, and I watched it 4 or 5 times and I still don't get it all because I'm not a network guy at all. But and the Docker documentation is outstanding, and there's also a Slack group called, I think it's called Docker Community. But if you go onto the Docker website, I think there's a link to it on the Docker website under Community. But I just joined that Slack group, and it's very, very active, some with Docker employees. Forums, I think. Well, it's in here. There's somewhere here in the Docker community page, there's a link to join the Slack group. And so usually whenever I'm having problems, that's how I figured out that you must alias the database, because I finally just went to the Slack group and said, why isn't this working? Here's my Docker Compose file. What's going on? And somebody just said, oh, dude, you need to alias your database.
Is there a Stack Overflow Docker?
There's quite a few questions on Stack, although I really don't find myself when I'm searching for Docker answers, I don't find a lot of that stuff on Stack Overflow. I wonder if there'd be more stuff. Yeah, none of the stuff comes up on the Stack Exchange either. So, what was the question over here? What does Okta do?
Yeah, that's what he asked.
Oh.
Oh, yeah.
So Okta does identity and access management as a service.
Okay.
So if you want, right now, their base product is, I'm an IT guy and I want my guys to be able to sign in one time, and then they can go off to Salesforce or Office 365 or whatever, and each one of those passwords for those products gets maintained by the IT group, and they randomly change. but you log in one time and you just have the one password that you have to change every 30 days or whatever your policy is, and it does a single sign-up. So I used to work for a company called Stormpath that got acquired by Okta, and for the developer part of it. So the developer part is you start up a .NET app, you bring in a NuGet package, set up a couple of config variables with like your client ID and your key, and you've got a login page, forgot password, email workflow, change password page, all that good stuff is already built for you. You don't need to do any of that stuff, and you manage all your users in our dashboard. So you don't no longer, like the login page is the page that fools you into believing you should build your own authentication, right? Oh, login is easy. And then you're like, oh crap, what if somebody forgets their password? Now I gotta create the email workflow, and now I gotta create all the user management screens, and all that stuff's already built. So I spent probably a third of my career building all this stuff over and over again for clients. Any other questions? That's a good question, by the way. I'll give you $5 afterwards for asking.
All right, let's give Lee a big round. I appreciate coming out.